Hey, what is going on? This is Hellbent, and this is a special little tutorial kind of conversation that I'm going to be doing. It's a special request from one of my viewers or one of my subs where they would like me to talk about the concepts and the ideas of my maze bot and how I went about creating it, what the ideas are of what it's supposed to do, etc., etc. And I'm going to go with that and expand upon it. Why, like what my end goals were with the whole project. Now, although this is going to have some elements of a tutorial in it, it's not going to be like a formal tutorial, and I don't have a plan exactly of what I'm gonna like. I don't have a chronological order of how I'm gonna present things. Some things I might do by typing it out. Other things I might just talk about. Some other things I might just perhaps use some paint and just draw simple graphics to describe what I'm talking about. But so keep that in mind. If you're not interested in this kind of thing, you should turn away now because this is gonna probably take a little while, and how long that is, I don't know. Also, um, because this isn't really a formal tutorial, etc., etc. I don't want to spend the time uh, uploading multiple parts to it or going into editing, etc., etc. So probably halfway through this or whatever, I'm going to probably want to go out for a cigarette. And because my recording software doesn't have the ability to pause, all I'm going to do is probably like put something on the screen that's like make the screen black or something, and then you can fast forward to when the screen's not black anymore. Because I don't want to pause the video, because if I pause the video, when I come back I might not actually continue. I might just put part one up and never actually do a part two to it. So anyways, I'll show you quickly the maze bot, or the original maze bot that I had created, and after it does its thing quickly, I'll discuss what I had in mind when I created it. Like, the idea of this isn't actually for it to create something that solves mazes, even though that it does solve the maze. Its primary purpose, like the reason why I created it, isn't actually to solve a maze. So you might have seen before. I haven't done too many games, but I've created a couple of games or game-like concepts. For example, this one here is probably the first one that I did with any kind of graphics on it. Right, so I have a little guy. He chases around, a little zombie dude, and he chases around brains and eats them, gets points, and if the lasers hit him, etc., etc. So I have a pretty good idea of how to create game elements, like, and how to track movement, how to detect if something collides with something else. But I wanted to come up with some other systems to see what I can do with it, come up with some new logic to actually create perhaps enemy players that do things besides just bounce off the wall, moving in a random direction or whatever, just bouncing and things like that, and better, more efficient ways of actually adding elements onto the game. Um, for the example of that one that I just showed, the brain one, all of those elements are created right at the beginning of the game, and even though if my player might eat a brain, that brain actually just gets recycled over and over again. I didn't have an ability to add more of them to it. It existed right from the beginning of the game right until the end. It was never actually destroyed. Once it was eaten, it would just be moved off the screen, or actually it was moved off the screen until it was time for it to be placed back in, and then it gave it a random position to put it back in. So I want to come up with ways of actually improving my ability to control game objects, add game objects, track their movement, etc., etc. Come up with some new logic ideas for AI, and that's why I started creating the maze bot. So the thing that set it off was I wanted to see if I can come up with an easier way of tracking um, the location of any object. So in that laser game, every single object in that, or every so the laser, they all had a defined width, a height, and a x and y location. The brain objects all had a specific x, y, width, and height. The player had a x, y, width, and height, and as they moved around, it would just update with their position, and then if those things I would do a check to see if they're touching each other. If they touch each other, depending on what kind of thing, if the laser hits the player dies. If the laser hits the brain, it respawns. If the player hits the brain, it consumes it, it respawns, but the player gets a point. Right? So I wanted to come up with a new system. So what I thought of was, you know what? What if I make a grid? So what if I can I make it as just a simple grid where a cell in my grid either has, so let's say if I'm just using one object, so either a cell will either have an object in it, like this one here, or it won't have anything in it, like these ones here. Right? Okay, so can I do that? Can I track this just by moving in a grid? So if this thing was to move, it would move one full grid space over, or one up, or however many, but it's always a particular cell within this grid either has something in it or it doesn't have something in it. Okay, so that's the first part. The next part was, okay, what if I have multiple different types of objects? So for example, with the maze, it has walls. So can I come up with a way where I'll make a wall a particular value? So I'll create something where a wall represents a value, and I ended up using numbers to represent those values. So I can do a check to see if a particular space has that number. If it has that number, it means it's occupied by that type of object. So I can have, let's say, two players. So I have a myself, and let's say I have an enemy player. The way that I decided that I'll represent these is by using a numerical value. So the enemy player will have their own unique numerical value, and my player will have a unique numerical value. Any empty space will have a unique will have its own value, and any walls or anything like that will have their own value. And I can do this for as many things as I want. So as long as I know what those values are, and then later on I can program the logic to decide what happens when any given object encounters one of the other things that are in that. So what happens when my player encounters a space that has a wall in it, right? Do I make it so it can pass through the wall? Do I make it so that if it touches the wall it dies? Do I make it just so that way if it can't move through that wall and it has to choose a different direction? So this was the concept. And before I continue, you guys will probably be able to take what I have and expand on it. I don't have any training in this kind of stuff. This is all off the top of my head when I came up with it. I don't have any programming language experience in any other programming languages. I only have a little bit of C and some AutoHotkey, and this kind of stuff. There really isn't a lot of coverage on this kind of stuff for AutoHotkey, so I have to come up with all this stuff off the top of my head. So if you have experience with other programming languages where that deals with these kind of things, you probably have some ways that you might improve upon what I've done, but I'll show you how I did it using AutoHotkey. So here like I said, I have the idea that I started with, where I want to be able to just use a grid, and an object is either in that any particular space within that grid. Any cell might have any number of objects in it. So what way can I represent this in code? And the way that I can represent that in code is just by using a simple array. Or in this case, when I started out, I just used 10 duplicate arrays or 10 arrays. And if I actually go down to the bottom where I actually have it planned out, when I first started, I would actually go through and write out everything. So this right here actually represents this. So if you look, I have a 1, which is this corner here. The cell beside it has a 1. So the 1s are all the walls, and the 0s are all the white space, or the space that the character can move through. So here I have my simple layout, and then I can use this to actually create this and actually program the logic to decide whether my player can move through it or not. So this is the basic framework of it. So once I had this idea worked out like this, and I admit this is a very bad way of doing it, but it's very easy for me to adjust it, and it's easy for me to understand the concept of what I want to do and make changes to anything, etc., etc. So for example, I'm not 100% positive, but I think, because it's been months since I touched this. I worked on it, and then once I was done with this, I moved on to the next thing. So I think that let me make sure if I save this, there should be a white space here now. Okay, so here you can see that if I make changes to my arrays, I can actually change the layout of this map. And hopefully this is the right spot. So that's the first thing I'm going to cover, is actually creating this. I'm sure that most of you will be able to figure this out quite easily, and I don't need to go into this. But just in case, you know what? Like I said, you don't have to watch this. You can go away. That's fine with me. But I'll show anyone who's curious about how I actually take this and make it into the actual graphical user interface here. Is all I do is I'll take this array. I'll borrow some code from here, so that way you don't have to watch for too long. Alright, so here I had started recording this like about an hour ago, but my mouse died halfway through and I couldn't find a battery for it, so I'm re-recording again. So I already have it set up where I have single instance force. I've set the working directory to be a folder within this, a subfolder that already has some images on it, and I'll show you the image. Anyways, it's just going to be like a black square, maybe a blue circle, and my escape. So I'm just going to paste in my array, and I'll actually adjust it so that way it lines up a little bit. Oops. Okay, so everything lines up, so I can see, when I go through it, I can actually see where everything is. Okay, so I have my array, which is going to represent the actual layout of the maze, and then I'll just go through and I'll make the GUI color white. I think when I originally created it, I actually used white squares. I don't know why I would have done that, but like I said, I just had an idea and I just ran with it. I made each of the cells, so each one of these numbers is going to represent a cell of 50 by 50 pixels, starting with the top left corner of the GUI all the way down to the bottom right corner. So I'll add an image. No, I'm going to borrow my code. I'm going to borrow my code that I had over here. So in here, I have it build adding the image of the images in a loop. So I'll just copy my loop. If you're new to AutoHotkey or programming, this isn't probably the best thing to jump into, because I'm not going to be explaining everything the way I would during one of my normal tutorials. I'm going to expect that you have at least some programming knowledge, that you're going to be able to at least somewhat understand some of the code that's on the screen and what it does. So here I have a nested loop. The outer layer represents the numbered arrays, and then the inner loop represents the numbers within it. So it just nests a loop and builds the GUI. So like I said, yeah, so here it's adding a white square. I'm going to get rid of that because I don't actually need that. So I'll just have it add black squares. Anything that's white is just going to stay white. I I need probably a couple of variables. So I need to create a variable to represent the Y slot variable. Set its starting value. I'll start it with 1. So when it starts, it's going to start with this array here, and the Y, I'm going to replace this 1 with the variable Y slot, and then as it loops through, it'll get incremented. So it'll start with this array here, and then the next time it'll do this array, and then this array, and so on. So that I also need a starting position for Y1. So here I've started in the, I'm going to start in the top left corner. So Y1 is going to be the position on the GUI. So it's going to be X1 and Y1, which is going to be, to begin with, 0 and 0. And then each time it goes through, because I'm using I'm going to be using an image that's 50 pixels by 50 pixels. Not sure if I said that, but I'm going to be using black square PNG. Oh, my bad. Didn't actually mean to do that. This isn't the right folder, darn. Anyways, I'm going to be using an image. I'll show you. I don't know why I'm bothering to show this. I'm just wasting time. I just want to make sure I'm clear on as many things as possible, so there's absolutely no confusion on things that don't need to be confused. So I have an image that is 50 pixels by 50 pixels. That is completely black. I've saved that to a folder, and I'm going to use that image to actually populate my GUI. So that's that black square. So wherever it encounters a 1, it's going to put one of those black squares, and then it's going to move to the next position. If it's a 1, it'll put a black square. If it's a 0, it won't put anything. Before, I had it set up that if it encounters a 0, it'll put a white square, but I'm not really sure why I did that. There's a lot of things I don't know why I do. But anyways, hopefully that should work there. The next thing I'm going to do is just show the GUI. And a width of 500 and a height of 500. Or in other words, 10 spaces of 50 by 10. Okay, so here is how I create just by using a simple grid like this to create my maze. Okay, so that's the first thing. When I expanded on this, I wanted to play around with much larger maps. And I ended up, the largest one I ended up making by using this same way is a 50 by 50. And when I got to this, it would have taken me forever to actually map out the maze like this. And I ended up actually using somebody else, a maze that I found online. And I'll show you how I created the largest map. There's probably way much easier ways than I did. In fact, when I was looking over this yesterday, I could see that the way that I built this map, if I spent just 5 minutes more on the script that I wrote to do it, it would have I would have saved so much more time. But I only planned on doing this once, so it was a one-off thing. It didn't matter that it took me like 20 minutes, 30 minutes to actually create this grid. So I'll show you the other ones that I had. I would just start with a basic template of all zeros, and then just go in and change some things to ones to create a maze. So here is one of my last mazes that I created, and I was just adding to it bit by bit, and I'll show that right here. Nope. Okay, there it is. Okay, so this one here represents this one here, where the first thing I did was I created the arrays. I left them all zeros, and then I just went in and changed some things to ones. And as you can see, I never ended up finishing this maze. I just wanted to play around with some different things. So here I went through, like I said before, I can just come in here, change it, different things to ones. And then when I run, if I was to run this again, now I have those 3 new squares, right? So after this one, this was a 20 by 20 grid, and I was, even at this point, I was like, oh my god, this is taking too long. I don't want to do it like this, but I do want to I want to see if I can step this up to 50 by 50 grid, or maybe 100 by 100 grid, maybe 1,000 by 1,000 grid. So the next one, I decided, okay, I'm going to grab somebody else's maze, and maybe I'll come up with a way of just grabbing off of it the image. So I just did a Google search, and what I was looking for was a simple enough maze that had a certain size, whatever, and one that was designed where the size of a black square was the same size as the white squares. So let's say if I took this image here, I could take this into Paint, and then I created a script that actually goes through. I would have to get the spacing right, but I would go through, I would set it so that way I knew the distance from the center of one square to the center of the next square. And all the script did was I would just press a hotkey. It would record whether it was a black square or a white square. So I'd use pixel get color. I'd just test, is it a black square or is it a white square? Record, if it's a black, I'd record a 1. If it was a white square, I'd record a 0. And then I could just take that and put it into my array. And I'll show you the basic thing. Like I said, this is a very, very bad script. If I'd spent even 5 more minutes on this, I could have improved upon it way more. Now, obviously I haven't adjusted it for the spacing that I have here, so it's not going to work exactly the way it should, but it should be enough to get the point. That's fine. So here. So the way it works is if I would try to center my cursor right about the center of a square, I'd press shift and it would record whatever the color is here, and then it would move over and record the next color. And I would just do this for however many squares or however many spaces I have. And I could just tap, 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 tap. Like I said, I could have automated it a lot easier. And then once I was done with that, I could take this and, I don't know, put it into a notepad to begin with, and then work on then I would have to reset this and start over again for the next line. Like I said, very, very bad way of doing it, but it worked. So I went through the whole maze, and it took a long, long time to do it. But in the end, I ended up with this. And then the same process happens as before, where I just take these arrays and I build them into a GUI. Right? I don't think I need to show that. I think this example there was enough to actually show you how it gets built. Let me see. The next thing was, so not only does this represent how it's going to get built, but it also represents my ability to perform logic on it. So let's say if when I add my player in, I think I change the value of the cell to a 2. So the 2 represents where my player is, and I want it to tell it where the goal was, but not how to get there. I gave it some kind of rules to follow and I'll go into this in a little bit more detail, but I gave it some basic rules that it would follow to try to get to the exit. So I would tell it where the exit is. It knew, like, programmatically, it knew how far it was. It knew how many positions it had to move up. It knew how many positions to the right or the left. But how to actually get there, I didn't tell it. But I gave it some simple rules that would help it find that exit. Which is why I said, I don't know if I mentioned it during this video, this isn't a maze solving bot, because there's much better ways that you can actually have something solve a maze. This is more like an insect. If I put an insect into this maze, and then I put a smell or a scent or something like that, it's probably going to spend a lot of time. It knows the scent's up there, but it's probably going to spend a lot of time in this corner trying to get up there before it finally says, oh, you know what, I can't go that way, so maybe I should go this way and try to get up there. Right? So I had a program in the logic to do that kind of thing, where I'm not telling it to go up and then across and then up and then across and then up and across. I just give it some simple rules that leads it kind of in that way. Okay, so I showed you how I create the basic layout, and there's probably way better ways. Like if I was using if I knew how to use GDI plus, I'd probably be able to come up with a much better way of implementing adding it in. But for me, for this project, it's just a one-off thing. It was fine to do it like this. Let me see. So I have the basic idea of how I create the grid. The next thing is I'll briefly touch on the logic of movement. And I'm not going to type it out. Maybe I'll show an example of how it looks when it's typed out, but I'll just do the principle or the concept of it. And you guys probably already know what it is, so I probably don't even need to spend any time on this, but just in case, I will. Okay, like I said before, if I have a 1 in a cell, it represents that there's a wall. And if I have a 0 in a cell, it represents that there is an empty space. Okay? And then I have my player represented by a 2 in the code. But it doesn't actually have to look at itself, so for most purposes the 2 doesn't mean anything. Okay, so let's say if I want my player to move only where it's allowed to, and the only places it's allowed to move is into an empty cell. What I'll do is I'll pick a direction. I'll look in each of the directions that it's able to move. So for these ones here, they're only allowed to move left or right or up or down. So this one here doesn't have to be checked. This one here doesn't have to be checked. This one here doesn't have to be checked. And this one here doesn't have to be checked. So it's only going to check these 4 directions. And the way I have it set up is I know as soon as I move into one of these cells, I update the values in that array. So it knows what array it's in and what position in that array it's in. Then all I have to do is if I'm not in this one here or this one here, all I have to do is look at the array above it or below it, above and below it. Actually, let me change this. So let me put my guy here. So let's say I'm here. I know exactly it knows exactly which array it's in, and it knows which position in that array it is. So in order to check to move, all I have to do is subtract 1 off the current array. So now I'll be in this one in the exact same position. So now I've just checked here. So I subtract 1 off of this array, and the exact same position. So now I just check the value there, and I can see that it's a 1. I check in the array that I'm in to the left, so I just subtract 1 off of its position. So it would be X array. So let me actually type it out exactly as it is. X array 8, and the position is 9. So this is where I am, and I want to decide how I want to move. So there's 4 directions I can look. There's up, down, left, and right. So if I want to look in the cell above me, or up, I would just look in X array 8. This isn't actually how you would type this out, but for -1 and the 9th position. So I would look in the array that I'm currently in, subtract 1 from that value. So I'd be looking in the 7th array, also still in the 9th position. So now I just checked that position there. If I can move into that cell, perhaps that's where I'm going to go instead of looking at the other directions. But if that's a wall, I need to now look in a different direction. So let's say that I know that I have to move up. What I'm going to first do is look in the cell that's above me. If it's blocked, if I can't move into it, now I have to decide what am I going to look to the left or to the right next. Now, if the distance let me actually move this guy again. Sorry, my bad. Let's say I'm here. Like I said, when I start the thing, he knows where the goal is. I don't tell him how to get there. I just tell him where the goal is. He knows that that's the goal. So he knows that it's 1, 2, 3, 4, 5 positions to the right. Right? So when it looks up here and sees that it's blocked, it's going to decide, okay, which cell is the next cell that I'm going to look at. And because the distance to the right is greater than the distance to the left, like obviously it's the exit isn't to the left, he's going to look in the cell to the right of him. Right? So that's the next cell that he'll look in. And once again, this isn't exactly how you would type it out, but just visualizing it. It's going to look in the same array that I'm in, which is number 8, and the position is going to be from this one here, it's going to be 1 over to the right, which I'm currently in the 3rd, so it's going to be 3 minus 1, or current position minus 1. Right? And once again up here I would actually do current array minus 1 to look up. And this would be like I said, this isn't a formal tutorial. I'm just free winging it here. So if it's taken me way too long to discuss this stuff, oh well. So it's looking in the current array minus 1 plus its current position to look up. It's going to look at the actually this would be if I wrote it out properly, it would be current array, current position within that array minus 1 to look to the left. So let me see if I have everything right here. I'll fix this. I'll make it actually the way you would type it out. actually the better way you would do this would be just use a multi-dimensional array, right? But this was a simple enough system for me to do. So if I want to look up, I look at X array, which is the name of the different arrays. They all have the same name. Which array that I want to look at, or that I'm currently in. So I'm currently in the 8th array, and I want to look, if I want to look up, I'll look the current array minus 1. So I'm in the 8th. If I want to look up, I'll subtract 1 from it, and now I'm in the 7th. And then the same position that I currently am within those arrays. So I'm looking from here, move up one array in the same position. If I want to look to the right, because I've decided that the distance is to the exit is greater in this direction than it is this direction, I've decided that looking to the right is the next thing that I'm going to check to see if it's open. Okay, to do that, I look at the value that's in the X array, the current array that I'm in, and my current position, or where I am within that array, minus, or no, my bad, this is actually plus 1. Plus 1. So I'll look at this cell. Okay, I can see here that it's a 0 position, so my character will change the value. He'll move over to this cell, and it'll change, as soon as it moves, it'll change this from a 2 to a 0, and it'll put my guy here, changing that to a 2. Okay, so that's the basic way that it moves, or looks to see which direction it moves. And of course, there's logic on deciding on which way it's actually going to look to decide to move. And I'll try to touch on that now. Now this part is probably going to be a pain, but I'll show you exactly the way that I had done it, which is very clumsy, but this is something I'll talk about in a little bit. Okay, so here is how I created variables that would store the value of where I want it to look. So if I want to look up one space in the up direction, it's the current array minus 1. If I want to look up 2 spaces, it's the current array minus 2. If I want to look left one position, it's the current array position, or my position within that array. So these are the positions within the array. And it's my current array position minus 1. If I want to look left 2 spaces, it's the current array position minus 2. If I want to look right 1 space, it's the current array position plus 1, and so on and so forth. So here I have if look up 1. So here's how. So it's just moved to a new position, and it wants to look around to see what it has available to move. If the value in that cell is a 0, it updates another variable to say that up one position is open. It also adds to a modifier, a points modifier, which I'll go into in a few minutes, where it helps it decide which of the, so it's going to look in all the directions. It looks in all 4 directions, and depending on what score it ends up having at the end, it decides which way it's actually going to go. Because if it has 4 directions that it can actually move into, how does it decide which one of those 4 to move into? And I did that by creating a point value. So if that space is open, it gets points added to it. If it's not, it just stays at 0. And the more points something has at the end, that would help me decide, that would tell it which way to go. I'm just looking for something that's okay. So once it's done all of its checks, and I don't remember all the scoring, like how I went through all the. I'll talk about like possible ways that you can come up with the point system once I get to that, but I'm not gonna. It's not necessary that you use the exact same system as I have. This was just off the top of my head when I came up with it. It worked well for me, so I used it. But I could easily see that there was many improvements that I could make upon it. So here's how I decided afterwards. After it looks at all those four directions and it got the score out of those four directions, here's how it would decide whether it was going to move or not. So if the up score was greater than the down score plus the left score plus the right score, it would move up. And this is just how it actually moves that ball from one square on one position on the GUI to the next position. So because I'm working with a grid, I need to translate that grid into actual pixels or X and Y locations on the screen. So if I take my grid here, the math for it is this is the first position within my array. But if I was to do where I want to draw the circle or where I want to start the circle or the square, if I was to use this times the size of the circle or the square, what I would end up with is it actually starting. So let's say I have a 3 by 3 grid, okay, and my character is right here and I want to draw it here. Because all this time I've been using a grid to represent everything, what I need to do now is translate that into actual pixels, X and Y coordinates of how to actually draw it. So this, even though this is a circle, it's actually a square. And I want to move it to this position here. How do I move it to that position here? I take its position within the array, and I subtract 1 from that value. Okay, so this here is the first position, this is the second position, the third, fourth, fifth, sixth, eighth, ninth, and 10th. I take its position within the array, so if I want to move to the 5th position, I take that position and I subtract 1 from it. Why? Because I don't want to, if I didn't subtract 1 from it, let's say if I wanted it to move to this one here, I would use the formula, its position within the array times 50 is the x equals x equals the position within the array times 50. Alright, so if I want to move to this square here, if I use just this simple, if I use this here to be my X position and Y position, what's going to end up happening is it's not going to draw it, it's not going to draw my square, it's not going to draw my square here, instead it's going to draw it here. Right, because 1 times 50 would mean that the X position would be 50, which would be here, and then a width of 50, height of 50. So I'd end up drawing it in this square instead of this square. So in order for me to actually draw it in the place that I actually want it to be, I need to subtract 1 off of the value of its position within the array. So like I said, I want to put it in the first position within my grid. If I subtract 1 off of that, that means I have a value of 0, and then if I multiply that by 50, I end up getting 0. So it knows that it's going to put my X position at 0 and then draw it in. Right? Likewise, if I want to put it into the second cell, I would have if I want to put it into the second cell, if I was to just simply multiply that by 50, which is the size of each of the cells, then I would end up getting 100, and it would draw my thing actually in the third position. So once again, I have to take my position, subtract 1 off of it, so I end up with 1. 1 times 50 gives me 50, which is actually the X position that I want to use. Okay, so that is coming up with where I want to draw it. And then I just move the image to that position, and I subtract, because I'm moving up. I take because I want to be able to track where my character is within this. So remember, I have this as a 2. Because I want to be able to track where my character is, and if I'm moving up, I want to change my current position from being an 8 to 7. If I move down, I take my current array and add 1 to its value once I've moved. If I move to the left, I subtract 1 off of from my current array position, which is so this is the current array, this is the current array positions. So if I'm just moving left or right, I'm not changing arrays, I'm changing positions within a particular array. And that just goes through that. Now I'll quickly go to one of the ways that I decide on what the logic is on how it moves. And in addition to this array, there's a second array, or a second set of identical arrays, that instead of storing values for whether it's a wall or whether it's an empty space or whether my player is there, it actually represents a point system based on how many times I've been to a particular place. So it doesn't matter whether I use positive numbers or negative numbers, but let's say each time I visit one of these cells, I'm going to take the score. So let me actually get a better copy, so that way I can alter it. So here's a copy of my second set that it's going to do a test on, and this is the places that my character has been, and it tracks as expected. So this tracks, it starts off with 0, and each time my character moves to a place, it adds 5 points, or I think I had it add 5 points to that value. So this, if my character was here, it would be 5, and then let's say it moved up to here, it would be 5, and then let's say 5, and then let's say it went all the way over to here and then down, and then it encountered a wall. So right now it's in this cell right here, and it encounters a wall. Well, the cell above it has a points. Actually, I should probably just go through and so these 5s represent the path that it has currently just finished taking. So it's down here now, and it's encountered a wall. And it says, okay, I have to go back the way I came. So whatever logic that I had that said, so let's say if there was a path open, let's say originally there was a path that it could have gone this way or it could have gone this way. Let's say for whatever the rules that it had it told it that it should probably go in this direction first. So let's say the exit was like something over here or something over here. So it had more reason to go in this direction than it did to go up. So it decided to go this way, but it encountered a dead end. Now when it comes back over to here, each time it moves over those cells again, it's going to add 5 to those cells again. So now these ones have a value of 10. And it comes here, it says, okay, here's a place I haven't been before. This is the way I'm going to end up going, because it has a choice. It says, do I go this way or this way? Oh, okay, this one has less points, so I'm going to move towards wherever the lower score is. Or another way of looking at the score is that this is pain. So if it's in a place that it's been to before, it's hurting it, right? So it wants to find relief, so it's going to move to the position that has less pain. So this position has no pain in it, so it's going to move there, and now it's going to change that to a 5. And it's going to continue. Okay, which way should I go? This way. Back here, there's pain, but if I move forward, there's less pain. But the exit's down here, right? So eventually, it'll get to the point where it says, you know what? The amount of pain that I'm going to suffer by going back over a place that I've been before is overridden by the fact that the exit's in that direction. So if I play... this one should probably be fine. So I'll probably do a visual thing here. Okay, so I think when I built these ones, I have a way of that I can start it so that way it automatically goes on its own, or I can control it just by doing a hotkey. So here, let me restart that. So here I have a couple of different rule sets that I've built in, and maybe I'll try to go over what the different rule sets are, and I can turn the rule sets. So basically the rule sets are just how it decides which direction. So let's say it's this blue dot is actually this black square. So here it has 1, 2, 3, 4 directions. What are the rules that determine which square it's actually going to choose to move into on its next move? And there's a bunch of different rule sets that help it decide, like, is there more points in that direction, is the goal more in that direction, etc., etc. So there's some different rules that I played around with, and I can adjust them to have different outcomes, and depending on what the maze looks like, it actually affects whether it's more efficient or less efficient. So anyways, so here it's obvious that it doesn't want to move back. Its goal is up there, so it wants to move forward, and it only has one option, so it's going to move into the next cell. And then it only has one option again, so it's going to move into the next cell. Now it has a choice again. Do I want to move back the way I came, or do I want to move towards the goal? The points towards the goal is it has more satisfaction moving towards the goal, plus it'll hurt itself if it moves backwards, so it's going to move forward, and again, and again, and again. Oh, there's the first time it changed direction, and I should have remembered that. I'll run it again. Okay, because of the rules that it has, it knows that it's supposed to be moving up. The goal, if it moves down, it's moving away from the goal, because the goal is up here, which is higher, in a higher position than it currently is. So if it moves down, it's actually moving away from the goal. But does that override its desire not to move into where it's going to hurt it, or into a place where there's negative points or positive points, or whatever I decided to do? It doesn't matter if it's negative or positive. It doesn't really, for all intents and purposes, it doesn't matter. It's just that maybe it wants to move to a place where there's more points, or maybe it wants to move to a place where there's less points. Either way, it works the exact same thing. So right now there is points up here, but because of the logic that's programmed into it, it says to itself that the points that that this has in it is still less than the gains it's going to get by moving in the direction of the exit. So it says I'm not going to move down, I'm actually going to go back over the place that I just went to. Okay, now it says, okay, the goal is over here, but I can't go this way, so you know what, I'm going to have to move down. So it moves down. No, okay, it moves, my bad, it moves to the, because now it's saying moving away from the goal, moving in the opposite direction of the goal is worse than moving to a possible direction towards the goal. So it's going to go that way, but now what it should actually do is go back. Oh, I actually don't know what it's going to do. Let's see. Okay, it's going to go all the way down. Okay, now it's going to go back towards the goal. And each time it changes the color, it represents how many times it's been in that position. And each time I believe the setup I have here is it adds 5 to that square. So if it's a blue square, if it's a white square, it has 0 points. If it's a blue X, it has 5 points. If it's a green X, it has 10 points. Yellow X, 15 points, etc., etc. So now it's going to decide, is it better to move away from the direction of the goal, or is it better to move over something that has negative 15 points in it, or positive 15 points? And it decides to move down. Now we're back where we were when it decided to move back up in the first time. Now, is the points that it's going to get, is it better to move into an empty square that's in the opposite direction of the goal, or is it better to go back up here again? And I guess we'll find out in a second. Okay, finally, it's better. It says, you know what? I have more satisfaction moving in this direction, so it moved down there, and now it'll probably just go off for a couple of spaces before it comes to its next decision, or its next real decision, which is here. Which way is it going to go? I think I have set the priority that the up position takes priority. Like I could do a random number. I think no, I don't think the priority is which is greater. Like, I think at one point I was considering it would take, so this is an array, and this is an array, and it'll calculate how many arrays away from it is, and then it'll calculate how many positions away it is, and whatever one is greater, it'll use that as the thing that it wants to move towards more. Like if it has a choice of left and right or up and down, which way is it going to choose? It's going to choose the one that has the greatest distance, or the greatest distance that it has to cover. But I don't remember for sure if I kept that in or if I gave it a priority of up. Up is a greater priority to left and right. I don't remember. So which decisions is it going to make? I don't know right now. I think it's going to go up, but it might go right. Okay, it went up, and it's very easy decisions from here. And I think it's just going to keep going up until it encounters the wall. So it's trying to move from the current array that it's in, or this line, all the way up to this line here. And as long as it can keep moving up into that line, it's going to keep moving up until it encounters a barrier. So now it's hit a wall. Which way is it going to go? My guess, based on what I've seen here, my guess is that it's going to go this direction, because this direction puts it closer to its end goal, or its position within the array. Right? This one would be the shorter path, but remember, it's not this thing isn't looking for the shortest path. It's just trying to get to that goal. It's not a maze solving bot. Okay, so there it goes, and it's going to encounter this. Now, my guess is it might go back the way it came, but then again, it might go down. I'm not positive. Okay, it went down. Right, and each time it goes over those squares, sooner or later it's going to the amount of points that are contained in them is going to say you can't keep going back over this space. You're going to have to take a new path. right? It came to this corner here and it said, I don't want to move down because if I'm moving down, I'm moving away from my goal. So here, I'm just going to start it. I'm going to press Control 1, which is my hotkey to start it, and I'm going to let it do its thing. And we'll be able to see what it decides by the color of the X. And eventually, because of the amount of points that each of those spaces is accumulating, eventually it's going to end up searching the whole map. And there it is. It's discovered the whole map, plus it's found the exit before. Okay, so that's one rule set, and there's a couple other rule sets. So this one is, its priority is to get to the exit with different boosts to the way that the point system works. This time what I'll do is I'll turn off the boosts. I don't remember if the boosts actually do anything when I put it into explore mode. And this time it's just going to use, I think I've set it that it still favors, if it has to choose between up and left and right, I think it's going to choose up. I think that's the way I mean, I can choose just to pick a random number, but it doesn't matter. For all intents and purposes, it works out to be the exact same thing of it having a priority or a direction that it favors. So in the end, it doesn't really matter. But with this setup, its goal isn't to find the exit. Its goal is to it's to move to places where the score is the least. So each time as it moves over different spaces, it builds the points up on those spaces, and it's going to try to stay where the points are least. And boom, it found the exit. Even though it wasn't trying to find the exit, it found the exit just by chance. Okay, and that is it for that. I also, like I said, I played around with a few different things that decide how the point system works and how it decides which direction to take. So I think I had that one activated before, but I don't remember for sure. So what I'll do is I'll put them both on, and I'll change the map because some of the changes actually make a much bigger deal depending on the size of the map. So I'll put it as this map, which is the largest map with these rule sets. And depending on what rule sets I have or how it determines which way to move, can greatly affect how long it actually takes for it to get to the exit. This map takes a while to build. Okay, so here's my little guy, and we will see what he does to get through this map. So this is with both of the boosts activated. You can see it doesn't like moving to the left because it knows that the exit's to the right. It also doesn't really like moving down because it knows that the exit's up. But as it travels over the same space over and over again, sooner or later, it has no choice but to go to where the points are less. So here it really wants to go up and to the right. So it's got itself stuck in this corner, but each time it passes over a position, the score is going to keep going up and up and up and up, and eventually it's going to have no choice but to go back to places that it's been before in a new direction. But it really doesn't want to go back that way. It really just wants to, you can see that it keeps staying right up here trying to get over to this exit over here. But gradually it's going to hurt too. The points just keep building up in here, and eventually it's going to have to come back down and try a new path. So what this shows is that, because if I was to put this on one of my other mazes, this might make it find the exit just like that. But on this one here, it was actually a detriment. So what's meant to be a boost on one map actually hurts it from finding the exit on another map. So depending on which map it is, there's different rule sets that'll aid it more than others, or be more of a hindrance. Okay, so it's found the exit anyways. Here I'll show it without any of the boosts. So this time it's still looking for the exit, but this time it doesn't have any of the extra boosts. And I'll go over the code a little bit for the boost, but it's basically what you would think. It's just extra points, like it'll check its position within what array is it in, which position within the array it is, how far away is the exit, how many points does it get for going over places that it's been before, does it want to go over those places, does it not want to go over those places. Alright, so here I'll let this one is, once again, it's trying to find the exit, but it doesn't have any of the extra boosts to its decision making on, like, which way do I go from here. So the boosts kind of are like, do I move up or do I move left, right? They're just extra logic to help to determine when there's a conflict, okay, I really want to go that way. Control 1. So once again, it's trying to find the exit, but it doesn't, I haven't actually told it how to find the exit. It's like a mouse or an ant or something like that. Some of you might be curious, or you might be curious of how I actually add in the X's. I think it's pretty simple or self-explanatory, but I'll show the code of actually adding the X's to wherever it is. Okay, so it found the exit, and it didn't do too well. So having no boost didn't do too well. I'll put boost 2 on, and we'll see how it does, and then I'll show how to change the X's. I think how to change the X's is pretty easy, but the X, there's like 5 or 6 of them, so they're just PNGs. Each X has its own color, right? Each PNG has its own color, and then I'll show you what determines how it gets put in. So here is with it's trying to find the exit. Last time it had none of the boosts added. This time it has boost number 2. I don't remember what the extra logic was for it. Maybe I'll have a look at that in a few minutes, but and it found the exit much faster. Okay, so like I said, depending on what the map is, adding these extra bits of logic that I have, and I'll show you in a minute what they are. But now for changing the X's, it's actually one of the first things I have in here. Now I can tell that when I wrote this, I was very tired, because when I'm very tired, I don't care about, I don't want to sit there and think through a problem, like how can I do it efficiently. It's just copy and paste and just change a couple of things. Copy, paste, change a couple of things. Like, I really don't care. You can say, oh my God, I would never copy and paste, but I don't care. Do whatever you want, I do whatever I want. So remember how I said that each time it moves to a different cell, each time it moves to a different cell, it would add 5 to the value of that cell. So it would have 10, 15, then 20, etc., etc. In this, it's just going to, each time it would go through, it would check what the value of that cell in that array is. And if it equals 5, it would it would add a picture with with the blue X PNG. Then if it went back over it again, the value would be 10, and it would just replace that blue PNG with a green X PNG, and then so on and so forth and so forth. So it would look at the places that it's been array, the current array, and the current array position. If it equals 25, K equals the current array, G equals the current array position. The X3, once again, this is the formula to actually make sure that I draw it in the right cell. So I take the position and I subtract 1 from it. So that way when I multiply it by the width of the cell, or the width of the image, in most of those cases it was 50, but in some of them it was like 20 pixels or something like that. Right? And then just change that image with the pink one, etc., etc. Let me see if I can find the boosts, the logic for the boosts. Functions. Find exit function. Okay. Okay, those are not really anything. Hmm. Okay, so here's some logic that's added in. If the current array, remember this is so I had 10 arrays, not the positions within those array. The current array is greater than the goal array. So in other words, if my character is below the goal, then it would say it wants to move up. If my player's position is above the goal, then it wants to move down. This is my first time looking at this stuff for months, so if I have that boost number 1 on, it goes to that function there, and I'll have a look at that in a minute. Left score. I think here, remember how I was saying before, like if it has 2 choices that are identical, let's say it has up and right, I think I programmed it to favor up over left or right. I think that's why here I'm not adding any points to a score, because it's already built into it that it doesn't need the extra points, whereas the left and right score in this case might be that it needs it, because it needs a way of actually determining whether between left and right, whereas up and down it doesn't need it, because it always favors, if they're both identical, it's always going to favor going up. I think we looked over much of this stuff here before. I don't remember why I do. Remember I said I don't remember how I did all this stuff. I'll try to go through it slowly so that way you can, if you want to, you can read over it. But I don't remember why I made all my decisions. Okay, so here's my extra boost function. If the current array, so my y-axis, if my y-axis equals player start y, so this is if I'm in the start position. If my current array equals the goal array, so this is if I meet the end goal, so if I end up getting to the finish line, if the current array or my y position is less than the y position of the goal array, extra down score, so add 1 to the score of my desire to move into the down position. Wait. It's less than. Okay. So like I said, I must have 2 different scoring systems. And one thing I did with one thing I'll point out here that I did with this logic is, even though sometimes I add in these extra point multipliers where it adds to the score, I don't want it to completely override the places bin points. So you remember each place that it goes, it puts points into that cell. I didn't want it to completely override that. So what I did was I would let this thing add to its desire to move to a particular cell, but once it got to about, I think I have it, so it would only do that 3 times, and then it would reset it back to 1 again. And this is what ends up happening with that is, how can I describe this? Okay. Sometimes you would see, so let's say I have a lot of different cells here. All right. Sometimes you would see it would move. Let's say it was starting to move down again, right? Each time it would move down, because it wants to move to a point that's above it, it would add an extra multiplier to move into the square above it. Or it would add an extra point to say, so let's say if it was 10, 10, 10, and here it was, let's say 8. Even though it wants to move to the place that has the least amount of points, each time it would move towards this direction, it would give it a bonus, so it plus, or in this case it would be actually like a subtract. And eventually, even though, no, I'm not describing it properly. Basically what I want it to do sometimes is I want it to be able to go places that it normally wouldn't be able to, but I want it then that to only get to a limit. Like, I didn't want it to be able to go into a place that had 1,000,000 points more than a place that was in the opposite direction but was moving away from the exit. So I limited it to a score of 4, so it could help it to go back into places where it wasn't supposed to go, so that way it might be able to find a new path up in that direction that was, had the points that it didn't want to go into, but I didn't want it to be completely able to override these negative effects of these points of the places it's been. So I said I did some testing, and I think I came up 4 was just after a little bit of testing where this seemed to be the optimal amount where it can go back a couple of spaces in a direction that it didn't really want to go to, but then if it didn't find a new exit or a new way to go, then it's going to have to go, it's going to start back at 1 again, which isn't going to be enough to override something that's been a place that has way more points. This is the second one. I don't remember how this one works. Let me see if the... So this one here looks like it's calculating my current array compared to the goal array, and it subtracts those two numbers and gets a value, and then does the same with the left and right. So it gets that and it adds, so if the left-right distance is greater than the up-down distance, so if the goal is further to the right or left than it is up and down, then it'll add points, extra points for its desire to move in this direction or that direction. Or it does the opposite if it's different. Then it's just the maps. Okay, so that was the maze. I'll do quickly. You can pause at any time. I'll scroll over everything quickly, and if you really want to duplicate some of this stuff, you'll be able to do it. But you're probably better off coming up with your own ideas. So you can pause the video at any point. And then I'll go into what my end goal was with this, because this was just for me to test out some ideas and what were those and where I wanted to go with those ideas, or what the next step of learning, because this was all about teaching myself new things. It wasn't about making a maze, I can tell you that. Had nothing. The maze is it's not insequential. It doesn't matter. Okay. The next thing that I did with this idea was I wanted to see how I could use what I learned from that and incorporate it into some other game ideas. I didn't spend long on this one here before I decided to move on to something else, but this shows some of that logic at play. So here I have myself, and here I have an enemy that's just exploring basically. So once again, it doesn't want to move to places that's been before, but this time if he gets within a certain he doesn't know where I am unless I get to a certain distance to him. I think it's 5 spaces. So if I get within 5 spaces of him, he knows where I am now, and he tries to find me like the exit. Boom. So he found me. It pops up a message saying that he found me. And if I keep within his radius, he's going to come back and get me again. Okay, so he's got me again. Boom, he's got me again. And he's got me again. And I also used this to, I'll let him go and do his thing again. I also used this to, I was going to do a Bomberman game, so this was like an early prototype to see how I could go about creating certain things. So I'm going to destroy part of this wall. like I said, I have these messages here because this is really testing. So here I got rid of a portion of this wall. Now I'll destroy another part. I don't know why, but for some reason, like I wrote the code really bad. Sometimes when I drop a bomb, it doesn't, this guy can keep going. Other times it stops him. I don't know. Um, One thing I can note here is that you can't see, if I place the bomb in this spot, you can't see it anymore, but if I put it in here, it's just because I used a different layer. But that, I put a bomb here, now it's gonna remove this part. Right, so that's where I was going with that. But also for him to be able to track me and kill me. So this is more of what that maze was, right? It's not about finding its way out of the maze. It's about being able to how does it decide to track things? How does it move, etc., etc. So okay, the next thing that I did with that was when I was working on this, I decided, you know what I really want to do now is I want to figure out how I can add multiple objects and being able to create them and destroy them and have multiple of them on the screen. And I wanted to use that grid system to see how I could use that, how effective that grid system would be in tracking multiple different objects. So that's where I came up with the pig script. So this was the next evolution of the grid idea, where this time now I practiced being able to add objects just by pressing a button, so I can create new things, new elements, new enemies, new characters at will, right? And then for them to be able to move and detect each other using a grid system to see how effective it is. So here they have just very, very simple logic where they only change direction if they encounter another pig or a wall, right? And then I have incorporated my ability to force them to change their direction. So if I leave forced move off, it's just going to temporarily change their direction to up until they encounter another pig or a wall, and then they can decide whatever way they want to go. Right, so I'll change all of their directions to up, and then once they encounter something, they can change directions again, or right, down, left, right? And then I have force move where I say, okay, I want you to move in whatever direction I want you to move in, but once you hit a wall or anything, you can't change direction, you just have to stop. And then here I can add I can add 100 at a time. So this is my first attempt at actually using objects. So before this moment, I had never used an object before in my life. This was my attempt at learning objects, and voila, I can create new objects. Still don't know classes though. I'm still working on that one. But I'll get it. I'll get it. Okay, so that was the pig script. Then I decided, okay, you know what? I can probably step this up and find some other things that I can do with that and come up with new ideas. So rather than working with the pigs, I went on to another thing where I went on to these little squares. And you can see, I'll show you the evolution of how this developed itself. So once again, it's just like the pigs where I have a surface and I want to create objects. This originally was squares, but yesterday I changed it to zombies. You're not going to be able to see it, but it's little zombies. Right, so here's the foundation. It doesn't have any features yet. I can't control them. I can just turn them on and off. Then the next step, rather than just adding to this, I said, you know what? You know it's better experience if I completely rewrite it again. So I rewrote it again and added a few new elements. This time it only has the blocks, but now I've added in my ability to force them, just like with the pigs. I can force them to move up, right, down, left. I decided, okay, I have that. Now what I'll do, is I'll add an extra direction. So up until now, they can only move up, down, left, and right. So the next time, I was like, okay, you know what? I'm going to add a new direction. So once again, I rewrote the script. And this time, they can now move in 8 directions. Is it 8? 1, 2, 3, 4, 5. 4, 5, 6, 7, 8. Yeah, 8 directions. So you can see some of them are moving on up, up left, down left, up right, down right. And each time they encounter another block, or if they encounter a wall, they change directions. And the code behind all of this is exactly the same as for the maze, except this time, because I'm not actually building a maze, what it has instead is just, this is the grid. So before it was maze bots. Before it was like this, where I had to come through and change everything to a 1 or a 0. By the time I got to here, it's just built inside of a loop. So the border, I changed the border around everything to a 1. So you can see that there's a black outline around everything. That has a value of 1s. So when my blocks are zipping around, if it encounters that, it means it's a wall. Everything else has a 0 or a 2. Each of these blocks, when they get added, it changes the value in that array to a 2. So this one here, it's surrounded by zeros. So it can randomly, when I create it, it randomly picks a direction that it's going to move in until it encounters a wall, and then it changes to a new random direction. Let me see. So this is just building the array. And by the time I got here, I'm actually just using a multi-dimensional array rather than having individual arrays like I did before. The objects themselves, I'm also using a ActiveX control, which I don't know a lot about. Somebody had showed me this, and I took what they showed me, and I've been just altering it basically to make it fit my needs. So I could show you how I did it, but I can't really explain it very well, so I wouldn't try to do a tutorial on it. Right? I could show you how I did it, but it's not really I don't usually do tutorials on things that I don't fully understand. But the reason why I went to the ActiveX is because when I did the earliest pig script that I had was built just using the normal controls, or even this one here is just, that's not the right one. Okay, this one's just using basic GUI picture controls. The other one uses it takes when I add multiple moving objects, it slows down once it gets to about 50 objects that are moving around, or 50 things that are moving around. You start to really see a significant slowdown in the performance. But by using an ActiveX control, I'm able to have like easily 100 before you start to see any noticeable slowdown. This is actually going to be running a lot slower now than it would if I wasn't recording. Like if I'm not recording, these guys are just zipping around at this amount. Let me see. So that was adding the, like I said, adding the new direction, so I can move up right, down right. So now it's 8 directions. The next evolution was coming up with a point system. Now the point system, I didn't end up bringing it to its final goal that I had with it. I've been thinking about it like over the last couple of weeks, actually restarting it and applying what I really wanted. So my end goal was to take these little bots, and for me to edit, all I would have to do is press a button or something like that, and they would have not only would the block have a position, so each of these blocks is an object and it has a X position in it, it has a Y position in it. No, it doesn't have an X and a Y. It has a position within the array, and then I calculate that onto the screen. But it has a position within its arrays, so uh, it's X and it's Y. It has a width and a height. It has a color. It has um, the direction that it's facing, um, except things like that in it. One of the other things that I was going to add to it was another number or something like that that would I would be able to cycle through them. So let's say what I'll tell. Actually, it's probably easier if I just tell you what I want it to do with it, and then I can perhaps describe how I was going to do it. All I would I want it to, so that way if I pressed a button, depending on at the beginning when I would start the program, a certain amount of blocks would be added. Now perhaps there would be extra blocks, but there would be a specific, perhaps depending on the pattern I wanted, there would be let's say a specific amount of black blocks, right? A certain amount of blue blocks, etc., etc. And what the goal was, that when I pressed the button, depending on what color and where in the pattern that I was going to create, these blocks here would have an extra thing, an extra trigger or an extra piece of information that said, when I press this button, these guys here, whatever the black blocks, are going to move to a particular part on the screen, and once they get there, they're going to stop. And then once all of these guys get to their position, it's going to trigger the next colors or the next blocks that have certain values in them to be directed to move to certain positions. And in the end, what it would do is create different patterns. So just to, because I don't want to draw out something elaborate, let's say if I want to create the auto hotkey logo, right? I think it's a white H on a green background with perhaps a little bit of a white trim around it. Let's say if I want to use these blocks to create that, I would have a bunch of different white blocks that I say, okay, move to these positions. Like, I'm not going to tell any individual, like this will be comprised of lots and lots of little blocks. I'm not going to tell this block here, to move to here. Instead, I'll say that I want them to move into this position here, and I'll discuss how they would actually move into that position, those positions. So I would say, okay, white blocks, assemble, create the H. After they're done, it would trigger the green blocks to start to fill in this space, right? And then lastly, some other white blocks would surround it and form the outside. And perhaps I would have some other blocks that are still zipping around, bouncing off of things, etc. Right? So I would press a button, and all of a sudden those blocks that are just zipping around like this. So first of all, the blocks are zipping around like this, and then all of a sudden I press a button, and all of a sudden they start coalescing into these different patterns, like the Transformers logo, or Super Mario, or whatever kind of pattern I want it to. And so I came up with what I have here is the early development of that concept of controlling these bots and telling them how to assemble in different ways by coming up with a point system. So I have, by me triggering this, there is depending on which of these options that I set, it goes over another array. And let's say if I want all the blocks to move up, what I'll do is this first row here, let's say I'll say that it has a value of 100. So I'll have the first array, everything's 100. The next underneath it, it's 99, and then 98, 97, 96, 90, all the way down to whatever. The lowest points here, the highest points are up here, and I say to the blocks, move to the highest points. So a block will be here. Let me stop. Okay, so a block will be here, and I say, okay, I want you to move towards where the highest points are, and so right now it can move this way, this way, this way, this way, this way, and it's going to look at the amount of points that are available in each of those new spaces, and the amount of points up here is higher than anywhere else, so it's going to move up, and then it's going to check again, so it's going to move up until it gets to the highest amount of points that it can. And if it gets to a place where it can't move to where there's more points, it just starts moving around, so that way other things can fall in, or so that way it doesn't act like gravity, so they don't get stuck on top of each other. So they'll actually spread out and completely move to the highest points. So here, I'll add 100. So right now I'm telling them that the highest points are at this top row, so they're going to start moving towards that top row. And they're going to fill themselves in. Right? Now I'm going to tell them that this corner here is the most points, and then the second most on an angle. So it's going to be the highest points are here, the lowest points are over here. So they're moving to where the most points are. And if I was to go back to this would be, let's say that it's a 3, it has 3 blocks across. I would probably do this, the center row here has the most amount of points. So any block that comes in is going to move to the center, that's going to get filled up, and then it's going to fill up the outside next. Right? Okay, so here's that. Now I'm going to tell them that this bottom corner is where the most points are. Now I'm going to tell them that moving down is where the most points are. And then down left. And up left. Down left. Right, so here's the idea where I can use different values for each of those different positions within my grid to control where these guys go without me directly telling them where to go. So they decide on their own where they're going to go based on me giving them some simple rules and okay. I think, let me see. I don't have too much more I can go into. The next thing that I did was, well, I meant to show this early on, but before I started working with the grid, I already had, like I said, I already had the ability to, I already knew how to make things move where I wanted them to go. Using a different system that wasn't the grid system. So here in this example, this was me testing out creating a homing missile. So this button here is a homing missile. This is me as a target. I can move around, and I'm testing a few other elements here. So when it hits me, something happens. What that happens is my character shrinks and I take damage. So I'm testing a few things. I'm testing tracking to a target, etc. So this is the precursor to a maze, finding its way or tracking to a maze. So let me move that out of the way. Oops. So each time it hits me, it's going to shrink me and respawn the bullet. But if I move around, it's going to track to my center. and boom, it hit. So that maze thing is basically the same kind of concept as this, where I have an idea, I need to flush it out, so I'll create a little project that helps me come up with ways of solving different logic problems. So that way I can incorporate those into future projects like games and etc. And the game that I had, the first game that I had made after I went through the process of learning how to create the maze, how to program their movement, etc., how to create the ActiveX control, or using HTML to control multiple objects, and etc., etc. The first project that I made after that was, let me see, I think it's in here. So after I learned, like I said, I learned how to, I used these projects as a way of learning how to actually use objects, because objects were a little bit elusive. Like, I mean literal programming objects, like with the keys and blah blah blah, right? Because all the tutorials I came across, they were like, oh, I don't like this. I didn't pick them up as easily as I should have, so I was like, you know what, I'm just going to force myself to come up with a project, and I'll force myself to actually learn how to use objects. And I used the objects to create. So after I did all that testing, the Bomberman thing, blah blah blah, this was my next thing, where now I know how to add objects at a whim. Like, I can spawn in new objects whenever I want. I can remove other ones when I want to. I can store their information in a data structure, such as an object, and etc., etc. Right? And this is the first real example that I came up with afterwards. Where here, I'm using an ActiveX to control multiple objects at the same time. Each one of these is added in when a new round starts. If I destroy it, it gets rid of that object. It doesn't just move it off to the side, it actually gets rid of it, and etc., etc. But that was this. And then after this one, I had created the last real project that I worked on. I think I've worked on some small ones since then, but I don't really remember. I spent a lot of time working on a couple of my auto clickers. Actually, one of the most recent auto clickers is the largest program I've wrote to date. It's over 2,000 lines of code. It's it's close to 100,000 characters. To give an example of what that works out to. So here I have this script here. It's 1,600 lines. I can condense some things, etc., etc. But it's only 38,000 characters, whereas the AutoClicker version 2.1 is so much more complicated than this ever was, and it's almost 100,000 characters. So big step up. So I spent a lot of time working on that project. As for the evolution of what I was doing with this, it was Pong. And the reason why I wrote Pong was because, like I said, I wrote those other ones because I wanted to be able to learn objects in a way that made sense to me to teach myself objects, because it's something that I'd been struggling with up until then. Every time I'd come across one, they would describe objects. Oh, it's a ball. You know how a ball, it has a weight, it has this, it has a this. No, an object isn't that. It's a freaking data structure. That's all it is. Describing it as a ball or something like that is just confuses it, just muddies it. It's a data structure. It's a set of data to do with a specific thing, like a form or whatever. And watching other people try to describe it as balls and blah blah blah, it just, I don't know. It didn't do well enough for me. So I needed to teach myself. I teach myself better. So I wanted to create this to be able to actually teach myself how to create a class. So that way, because that's another thing that I have no experience with. And when I try to go look up things on classes for AutoHotkey, I can't. They have the context doesn't work for what the kind of things I want, so I can't pick it up like that. It would take me. It'd be like pulling teeth, and I don't want to pull my own teeth. So because I already know how to do these things without using classes, it's like, do I want to invest the time in something that I'm not even sure I'm gonna actually be able to figure out, or I already know how to do it? Why do I want to waste my time uh, going through these things that there's a question mark at the end goal? Like, when I'm done this, when I finish looking up this thing that this person has done, when I'm finished that, am I going to understand how to incorporate it into my own projects? And the answer is, I don't know. There's a big question mark there, so I don't want to spend the time on it. And then when I go to other um, programming languages, I've looked up a few things on them, but they'll have so many things that are very specific to that programming language where I can't really translate it into AutoHotkey. I don't know okay, is this a special thing for that language? How would I do that in this? So there's so many, once again, there's all these questions that I have where I don't know what the end goal is going to be, so it's hard for me to convince myself to invest the time to trying to learn something that I don't know if I'm actually going to, there's something to learn from it. So what I wanted to do here with Pong was I wanted to write it out and then figure out how I could actually make Pong as a class or an object-oriented program, which is something that I want to get into, but I don't know. This is the only programming language that I have besides C, which definitely is not program object-oriented. But halfway I got through this and writing it the way I would normally write out my logic and everything, and I got bored, and I decided, you know what, I'll just finish it off and I'll just release it, and then maybe later on I'll come back to it and work on it and try to build it into classes. Now, if you, the person that's watching this now, if you think that you could teach class or object-oriented programming in an AutoHotkey sense using perhaps something like this, where I have, a paddle, a ball, and an arena or whatever, if you think that you can create a lesson on that, please do. Please create a tutorial on it. I would love to see it. And if you make it on something like this, then I can translate it to myself, and then from there, once I do it the first time and understand it, doing it the first time, I can just go from there. I'll never have any problems again with it. I just need to crack that first time. So if you watching this if you think that you can do a good job of teaching classes and methods and all that other techno bullshit, if you think that you could do a good job at it, I would love to see a tutorial on it. Alright, I think that's everything. If I left anything out, just let me know and I'll do a follow-up thing on it. Like if you have a specific thing within this, we can discuss it down in the comments, or I can make a follow-up video. Right. I'll show my Autobots. Is this the last one? I thought it was Autobots 4 was my last one. Yeah, Autobots 4. Wait, didn't I have Autobots 4? Mazebots, Autobot 1, 3, 4. I might have closed it. Yeah, I'm pretty sure I showed this one. So once again, this is just using the point system. So they're going to move, the most points are up at the top. The most points are down to the left. So now it's going to come, and it's going to form up there. Okay. So I'll let you look at, oops, I need to put my cursor. So I'll just scroll over this and you can pause it, whatever you want. I'm not saying it's good, I'm not saying that you should use this one, but it could be maybe a launch point. Here, I don't know if that was going too fast. You know what, I have no choice, I have to go fast. This is a long script. If you have a question of can I post this onto Pastebin or something like that, the answer is no. I'm not going to be posting any of the code. In fact, normally I wouldn't even share the code like this. So the answer is no, don't ask me. I'm not going to be sharing it. All rights reserved. Okay. If for the one of you that's still here, hope you enjoyed. I hope you picked up something. Hope you learned, come up with some improvements. If you do come up with some improvements, maybe make a video of it. You don't have to talk during it. Just show what you come up with, and because I would love to see what kind of things other people do. Because there's not a lot of examples of doing this kind of stuff with AutoHotkey, and I'd always love to see